The center of the Milky Way is a story of intense radiation, gravity, and mystery, a place where the forces of nature are pushed to their limits. But what if our own planet were to find itself in this cosmic theater? What would happen if the Earth were located there and somehow managed to survive? Let's start this journey to the heart of our galaxy and find out. Picture this. You're floating in space, surrounded by billions and billions of stars. Suddenly, you see a bright, swirling mass of gas and dust in the distance. That, my friend, is the Milky Way galaxy, our home in the vast expanse of the universe. The Milky Way is estimated to contain over 100 billion stars and is about 100,000 light-years across. In other words, if you were traveling at the speed of light, it would take you 100,000 years to cross the Milky Way from one end to the other. It's a couple trillions of miles. And it isn't just a static collection of stars and gas. It's a dynamic, evolving system. In fact, the Milky Way is currently hurtling through space at a speed of about 1.3 million miles per hour. One of the most fascinating things about our galaxy is its shape. The Milky Way is a spiral galaxy, which means that it kinda looks like a disk with a central bulge and spiral arms. The spiral arms are the areas where new stars are born. It's where the most stars, gas, and dust are concentrated. And this is where the solar system is located. Our system is like a tiny speck in the grand cosmic tapestry of the Milky Way. It's about 26,000 light-years away from the center of the galaxy, a pretty long distance, isn't it? The solar system is also moving through the Milky Way as it orbits around the galactic center. It takes about 230 million years for our system to make one complete orbit around the galaxy. Just imagine that. Since the time of the dinosaurs, we've traveled just a quarter of this way. The position of the solar system in the galaxy affects our life in many ways. For example, things like the amount of radiation and cosmic rays we're exposed to, and even the likelihood of asteroid impacts and so on. Also, thanks to our location, we can enjoy some pretty amazing views of the universe around us. From our vantage point in the Milky Way, we're able to see other galaxies, nebulae, and star clusters in breathtaking detail. We're also a part of a pretty happening neighborhood, with lots of other stars and planets nearby, so we're lucky fellows. But what would happen if we weren't so lucky? What if the Earth was located in the center of the Milky Way instead? The center of the Milky Way is home to a region of space called the central bulge. And it's just packed with stars. It's like a disco ball, but instead of shiny mirrors, it's covered in stars. Only this disco ball is really huge, about 10,000 light-years in diameter. The center of the Milky Way is also home to some extreme environments that would make even the bravest astronaut shiver. High-energy particles and intense magnetic fields can wreak havoc on electronics and spacecraft. Intense radiation fields can fry anything in their path, so it's not exactly a friendly place for life as we know it. So, if the Earth were located somewhere closer to the center of the Milky Way galaxy, it would be a very different place. Let's take a look at some of the potential effects. First of all, radiation. As we mentioned earlier, the center of the Milky Way is one of the most radiation-dense regions in the galaxy. It would make life on Earth very challenging, if not impossible. Sure, we have the Earth's magnetic field. It's like a giant shield that protects us from harmful radiation from outer space. But could it protect us if we were located in the center of the Milky Way? Unfortunately, the answer is no. It's kind of like trying to use a tiny umbrella to protect yourself from a massive storm. So it would be an easy win for the galaxy. But it's not all doom and gloom. There are some brave organisms that are able to adapt to high levels of radiation. We've seen that life on Earth has evolved to survive anywhere, from the depths of the ocean to the icy poles of the planet. So let's imagine what would happen if we somehow evolved to survive in these harsh conditions. Like, picture humans with tough, scaly skin that protects them from radiation and plants with unique structures that allow them to thrive in this bright environment. In that case, radiation still could have some seriously spooky effects on us. For example, it could damage DNA molecules and cause mutations. Imagine a world where plants grow with 5 leaves instead of 4, animals have strangely colored fur, or people have unusual eye colors or other unique features. And these are just some of the best examples. Let's not dive into the bad ones. Also, it could cause us to undergo some metabolic changes. Maybe our bodies could process food and other resources more quickly, which could lead to faster growth rates and larger sizes. Plants could grow tall and thick, and animals would be much larger than usual. There are also some organisms on Earth that are able to bioluminesce. Thanks to high levels of radiation, these organisms could potentially glow even brighter than usual. Imagine walking through a forest at night and seeing trees, mushrooms, and even insects glowing with an eerie blue or green light. Frightening and amazing, isn't it? But let's move on to the next big change: gravity. The gravity in the center of the Milky Way is incredibly strong, all thanks to a supermassive black hole, which is about 4 million times the mass of the Sun. This black hole is called Sagittarius A, and yep, it's our neighbor now. Great. And assuming we don't get swallowed by this black hole or crushed by this incredibly strong gravity, it still could trigger lots of earthquakes and volcanic eruptions. This black hole would be like the gravitational bully, pulling and tugging at everything in its path. Basically, if we survived this, we'd have an epic surfing competition every single day. Just add a bit of thrill of risking your life, and forget about running away from the planet. No easy rocket launches anymore. And physical objects won't be the only ones affected by gravity. Time would flow very differently for us. According to Einstein's theory of relativity, time passes more slowly in areas of high gravity. In other words, Earthlings would age more slowly than someone far away from the center of our galaxy. Also, the center of the Milky Way is a very busy place. Stars, planets, and other celestial objects moving around at incredibly high speeds there every day. The positions of stars and other objects would constantly be changing. In other words, say goodbye to normal navigation. The GPS systems would likely be unreliable due to the strong gravitational forces and high radiation. So if you accidentally got lost in a glow-in-the-dark forest with some creepy animals, good luck. But it's not all bad. The center is also home to molecular clouds. These are the regions of space where new stars are born. And the Milky Way in general has some pretty amazing sights to offer. For example, stunning nebulae like the Orion Nebula and the Eagle Nebula, which are visible with telescopes or even just a good pair of binoculars. So, if Earth were located in the center of the Milky Way, we would have a front row seat to some of the most spectacular cosmic events. Wouldn't that be awesome? Overall, if Earth were located in the center of the Milky Way, it would be a very different place. Of course, we all understand that our planet wouldn't have survived such a change, but it's still pretty interesting to imagine how our life would flow if we were there. And judging by what we just discussed, it wouldn't be pretty. So let's treasure and appreciate our small, quiet solar system. Astronomers have recently found a strange object far away from Earth. It disappears every 2 minutes and sends out waves of radio noise 3 times in 1 hour. It was first seen by a student named Tyrone O'Doherty while he was looking at the sky in his home country, Australia. This space object appears to be different from anything else we've seen before in space. Because of their calculated movements, scientists call these types of objects transients. Turns out, they are not that rare to find. When scientists study transients, most of the time, they look near a big star or near the things it leaves behind after it goes out. Transients come in all sorts of shapes and sizes. Some transients are slow, take a few days to appear, and stay around for a couple of months. Other transients are very fast and only appear for a second. But there are not many transients that are in between these two speeds. It's what makes this latest discovery very special and unexpected. Speaking of weird things we've found in the universe, the toughest object we know of is made from the remains of a star that has faded away. Scientists have found out through experiments that when the center of a faded star is squeezed by a lot of gravity, it turns in a type of spaghetti-like material that is extremely strong. Even if you could technically touch it with your hand and try to break it, you would need to use 10 billion times more force than it takes to break steel. Planets can be weird too. Haumea is a perfect example. This dwarf planet moves around the sun far away from Earth, beyond Neptune. It's different from other planets because it's shaped like a sausage and has 2 small moons. It also spins very fast. One day on this planet is only 4 Earth hours long. In 2017, scientists saw something strange when Haumea passed in front of a star. They noticed very thin rings around it, which probably appeared when other various space objects were hitting each other in its vicinity a long time ago. Ever heard of a moon? It's a fancy name for a moon that orbits another moon. People on the internet let their creative side go wild with this one and gave it all sorts of different names, like submoon, moonito, grand moon, and moonette. This kind of object is just a theory right now, but scientists think it's possible that it might exist. Maybe someday we'll discover one. There are many strange moons in our solar system, like Io, which is very volcanic, and Triton, which has geysers. But one of the weirdest looking ones is Hyperion. This one is a rocky moon with many craters that looks like a pumice stone. A spacecraft called Cassini also found that Hyperion has a beam of static electricity flowing out from it. The reason for this weird activity is still up for debate. Not all stars behave the same either. When a scientist named Tabitha Boyajian, pronunciation here, https u2.b f8vy63um 56, and her team looked at this star called KICE 846285, they were confused. Also known as Tabby's star, this space object would dim unexpectedly, sometimes for as much as 22%, for random periods of time. However now, most people believe that the star is surrounded by a strange ring of dust that makes it look darker every now and then. Some galaxies are equally unusual. DGSAT I is a type of galaxy called an ultra-diffuse one. This means that it is very big, similar to our own Milky Way galaxy, but it has very few stars and is hard to spot with regular telescopes. Scientists discovered DGSAT-Y in 2016 and noticed that it was all by itself, which is unusual for ultra-diffuse galaxies. This means that DGSAT-I is very old and formed a long time ago, about 1 billion years after the beginning of the universe. NGC 247 is another weird spiral galaxy that looks almost made up. It is smaller than the Milky Way and has bright areas where new stars appear. However, there's also a dark void on one side of the galaxy's core that looks like a hole. Some theories suggest that this void could have been caused by gravitational interactions with another galaxy, or a blob of dark matter. Another theory suggests that it could be the work of another civilization building something weird in there. The Exotica catalog lists some unusual galaxies that might have big civilizations living in them. Scientists are trying to build new telescopes that will make it easier to find them. The Vera C. Rubin Observatory in Chile, for example, will be able to look at the entire sky repeatedly and see if there are any changes that could help us locate some foreign space cousins. Just in case you ever stumble upon this word, a neutrino is a particle smaller than an atom, with no electric charge and a very small mass. They are produced during nuclear reactions, such as those that occur in the sun. Neutrinos are extremely difficult to detect because they interact with other types of matter very weakly. Scientists use large underground or underwater detectors to spot neutrinos. They study their properties to gain a better understanding of the universe and its origins. On September 22, 2017, a powerful neutrino hit Earth. This kind of thing happens often, but this one was special because scientists were able to figure out where it came from. They discovered that it was sent to Earth 4 billion years ago by a very big black hole in a galaxy that was eating up everything around it. Do you think you have an impressive jewelry collection? Wait until you hear this. Astronomers have discovered a planet that is mostly made of diamond. The planet, called 55 Cancri E, is a superplanet and is located in our Milky Way galaxy. Scientists believe that at least a third of the planet's mass is pure diamond. This is the first time a rocky planet with this kind of composition has been discovered. 55. Cancri E is very different from Earth, as it has a lot of carbon and is very hot, making it unlikely for life as we know it to exist on it. We've learned a lot of things about the universe with the help of our trusted Hubble Space Telescope. One of the most famous images taken by it is called the Pillars of Creation. This is a photo of a region of the Eagle Nebula where new stars emerge rapidly. Captured in 1995, this picture allowed us to see massive pillars of gas and dust towering above the nebula, and has become one of the most iconic images of the universe. Some of your friends might even use it as wallpaper on their phones. The sun we spin around is a lone wolf. In reality, many stars in the galaxy have companions. Castor is one of these. It's a group of 6 stars that make up one of the brightest and most beautiful systems in the night sky. People have been looking at Castor for a long time, but they hadn't known it was actually 6 stars until telescopes and spectroscopes were invented. Even with a small telescope, you can see that Castor has 2 main stars, Castor Ea and Ba, that orbit each other. These stars are bigger than the Sun, and it takes them 467 years to orbit each other. Scientists from Asia found over 500 stars that are way weirder than those we've been familiar with. They move quickly around the center of our galaxy, the Milky Way. Some of these stars move so fast that they will, at one point, leave the Milky Way. The team behind the project used 2 telescopes to study these stars and properly understand their speed. These days, we call them high-velocity stars. You are driving down the highway, and an 18-wheel tractor trailer is coming up fast behind. You've got to change lanes. You look in the mirror. Is there enough space? And you notice the words on the mirror. Objects in the mirror are closer than they appear. No kidding! It is the same with the Milky Way galaxy. There's another galaxy headed this way, and like the tractor trailer, it's closer than it looks. The Andromeda Galaxy, or M31, as it was labeled originally by Charles Messier in his catalog of 110 fuzzy objects in 1774, is now officially named NGC 122. That's New Galactic Catalog 122. A spiral galaxy larger than the Milky Way, the Andromeda Galaxy is so big and so close that you can see it without a telescope. In fact, it appears with the unaided eye half as wide as the Moon. It is estimated that the Andromeda Galaxy contains 1 trillion stars compared with the Milky Way's estimated 400 billion measly stars. To see the Andromeda Galaxy, you must allow your eyes to become dark adapted. This might take about 10 minutes while your pupils dilate to take in as much light as possible. M31 is best seen from late summer through winter when the Great Square of Pegasus, the winged horse, is overhead. Draw a line across the Great Square diagonally upwards from the lower corner star, and then go a little further beyond the square. There it is! But you still won't be able to see how big it is unless you peek at it from the corners of your eyes. If you stare straight at it, the galaxy will tend to fade away. You must use your peripheral vision to see how big the Andromeda Galaxy appears. Peripheral vision, or averted vision, allows you to see light more sensitively at night, but without color. Sailors have used averted vision for centuries to see faint lights out on the ocean or on land. Aristotle used averted vision to observe star cluster M41 in Canis Major, as he described in his book Meteorologica. In a telescopic photograph, the Andromeda Galaxy appears 6 times wider than the Moon because with the unaided eye, we can only see the bright center of the galaxy. A telescopic photograph shows how massive M31's spiral arms really are, and this beast of a galaxy is headed our way. We are looking at a future massive collision of galaxies of, well, galactic proportions. When that happens, humanity may need to relocate to another galaxy to inhabit. Perhaps we'll go to the Pinwheel Galaxy in the asterism of the Big Dipper. How do we know the Andromeda Galaxy is moving toward us? With a tool called a spectroscope. After the camera, the spectroscope is the most important attachment to a telescope. Oh, except for the human eye. Our eyes only see light. You don't have this big horse in your eye. You only have the light being reflected by the horse in your eyes. The same with space. We only see the light coming from there. So if we are going to understand space, we need to understand light. And that was not an easy task for astronomers of the 19th century. The invention of the spectroscope was a big breakthrough in understanding light coming to Earth from space. With a spectroscope, astronomers can tell which direction objects in space are moving, as well as which elements are making the light. When you hear an ambulance approaching, you hear the siren getting louder and higher, and when it passes you and goes away, you hear the siren sound get weaker and lower. The change in pitch frequency depends entirely on the motion of the source. This is called the Doppler effect, after Austrian physicist and mathematician Christian Johann Doppler, who first explained the effect in 1842. The ambulance's siren is not changing its volume. The sound waves are being compressed as it is approaching and stretched as the ambulance recedes. The spectroscope shows that light waves show the same Doppler effect as sound waves. They are compressed as the star or galaxy is approaching us and appear stretched when it is receding. Therefore, the light from an approaching galaxy will appear slightly bluer, blue shift, a slight increase in frequency, and the light from a receding galaxy will appear slightly redder than normal, red shift, a slight decrease in the light's frequency. In 1929, Edwin Hubble, after whom the Hubble Space Telescope is named, published his spectroscopic study of 46 galaxies, the light from all but one of which were red shifted, moving away. Hubble's study provided the first evidence that the universe was expanding. The farther away a galaxy was from the Milky Way, the faster it was moving away. This was also the first evidence that the universe began with a Big Bang. The one galaxy whose light was blue, shifted, moving towards the Milky Way, was M31, the Andromeda Galaxy, the closest galaxy. 250,000 rmph seems a pretty high speed at which to have a collision. That's the speed spectroscopic measurements of the blue shift of Andromeda indicate. It's going to be a big mess when it happens. But when is it going to happen? To determine when the two galaxies will collide, we need to determine the distance between them. And for that, we need, boom, supernovas. Type 1a supernovas are what are called standard candles. Just as we know how bright a candle shines, we know how bright a Type 1a supernova shines. Its absolute magnitude. A Type 1a supernova appears when a white dwarf collapses under the pressure of all the gas it has been gravitationally slurping from a companion star. Looking at the Andromeda Galaxy and measuring the apparent brightness of a supernova in the galaxy, it is possible to calculate its distance away. Because the intensity of light dims inversely with the square of its distance away, which is called the inverse square law, by comparing the apparent brightness of a supernova in the Andromeda Galaxy with its absolute brightness, voila, we get an approximate distance of 2.5 million light years. Since 1 light year is approximately 6 trillion miles, and the Andromeda Galaxy is 2.5 million light years away, even though it is approaching at the speed of about 250,000 mph, we have about 4 billion years before the big collision. So you can wait until after lunch, maybe dinner, to start packing. As an aside, if we see the Andromeda Galaxy as it was 2.5 million years ago, and it has been moving toward the Milky Way all this time, how big in the sky would it appear now? Quite as big as that tractor trailer in your rearview mirror. But do we really have 4 billion years before the galaxies crash? There are several other factors to consider. The minor galaxies that are gravitationally linked to both the Milky Way and the Andromeda Galaxy will be swallowed up by their host galaxies. Considering the lopsided mass distribution that will result, the galactic collision of the Milky Way and Andromeda will be affected. Some scientists are saying it won't be a direct hit, but more of a sideswipe. And then there's the galactic halos of each galaxy. Here's what Project Amiga has found out about the halo of stars and gas surrounding the Andromeda Galaxy. Using the Hubble Space Telescope, researchers were able to observe how the light from bright distant quasars was being absorbed by the mostly invisible gas around the Andromeda Galaxy. Look at the results. Notice M31 in the center. If the same is true of the Milky Way, and there is no reason to think it would be different, then the halos of the two galaxies are touching now. The collision has already begun. There is also a question about what effect the dark matter clouds around each galaxy may have on an impending collision, or are having now. But enough of speculation. In 4 billion years, the sun will have increased brightness on its way to becoming a red giant star, and humans will have already found another galaxy to inhabit. Happy traveling, dear humans. When you look at the night sky, it seems like there's not much happening up there, and that the stars always twinkle at the same spot. For thousands of years, researchers followed the idea that the lights in the sky were unchanging. Sailors guided their ships using fixed stellar patterns. There are also the exact outlines of constellations we observe today, and astronomers identified them a long time ago. It seems impossible that one day we wake up and simply can't see some stars anymore. Or does it? A team of researchers, vanishing and appearing sources during a century of observations, VASCO, studied the sky to check how things with the stars are going. The astronomers got the data from Gaia, the European Space Agency, and compared the information from 70 years ago to that from today to see how the sky has changed. To test it right, they had to use both modern and old telescopes. And something really interesting happened up there. Over 700 stars from the old maps were missing. If one star disappears, multiple theories could work. But it's harder when hundreds of them vanished at the same time. Could it be the data was wrong, or these stars were too faint to detect? Nope. They quickly eliminated this option because these stars had clearly been part of their earlier observations. So, the first thing that comes to mind when talking about how stars disappear is that they reach the point where they ended their lives. You can have the most massive stars of all, and we're talking about those that are way heavier than our sun, and they go through sudden changes as they get to the end, which we also call a supernova. It's a powerful explosion that later shines for many, many months, and it's still visible even across hundreds of millions of light years. But that's the point. You see the traces unlike here. Could this be a failed supernova? That means maybe one of them collapsed but turned into a black hole and consumed the remains from the inside out without causing a powerful explosion. But no one's been mentioning any signs of a black hole being active anywhere near those stars. And what if the stars had become less visible because of dust or gas around them? This is something that can easily happen, as interstellar dust and gas do block our view of objects that are far away. But there were no traces of unusually high concentrations of dust or gas. Nothing destroyed them either. Researchers would have seen traces if something like that had happened. Plus, these missing stars were not all in the same area, which means there probably wasn't just one fatal thing that made them all disappear. Also, the stars were not at the same stage of their life. So it's not an option they were all accidentally close to their end. They weren't particularly old or young, and they were on different levels in size and brightness. At some moments, it even seemed these stars haven't vanished because of some natural events. Maybe it was something related to other civilizations that might be somewhere out there in space. Maybe that's one of the ways to look for them. We could stumble upon some secret civilizations from other planets if we carefully observed the behaviors of stars, especially those we can't explain. No one knows what exactly happened with the missing stars, and unfortunately, right now, all we have are these theories. But you have to admit they're cool, though. Maybe it's just some kind of optical afterglow caused by gamma-ray bursts, or maybe even fast radio bursts. Fast radio bursts, FRBs, are powerful pulses of radio waves. They can release more energy in a couple of thousandths of a second than our giant sun does in almost 100 years. We don't really understand how these energy eruptions work yet, so we don't know what they can do. But still, hundreds of stars at approximately the same time. There are between 100 to 400 billion stars in our galaxy, so we'll probably see some of them disappear too. Hopefully we'll understand better why such things can happen. Of course, scientists are not sure about this number because we can't see all of the Milky Way stars from our home planet. Some are too faint, some are too far, or even hidden by dust or gas. But they assume these numbers based on the size, shape, and likely mass of the Milky Way. And out of billions of stars, there are a little over 9,000 of them we can see with the naked eye. If you want to see more, you need a good telescope that will reveal those fainter ones your eyes are unable to discern. Many of the stars we see in the night sky are probably not alive anymore. Stars are giant balls of gas that produce light and heat through nuclear fusion in their cores. However, stars also have a limited lifespan, and eventually, they run out of fuel and stop shining. When a star passes, it can either become a white dwarf, neutron star, or a black hole, depending on its size. Scientists have discovered that some of the stars we see in the night sky are too old to still be shining. This means that they may have faded, but we are still seeing their light because it takes so long to reach us. Actually, we may be looking at the past when we look up at the stars. Check out all of the stars you can see with your bare eyes. They lie within about 4,000 light years of us. That means what we're seeing are stars that appeared 4,000 years ago. Most of the stars we know of exist within galaxies, which are massive collections of stars, gas, and dust held together by gravity. Still, there are large areas of empty space between galaxies too, and the question is, could they have any stars? It seems that these areas of space are not completely empty. There is still some gas and dust, as well as dark matter, which is a type of matter that we cannot see, but we know exists because of its gravitational effects on other objects. Scientists have even discovered a few isolated stars in these areas of space. These stars didn't form there. They ended up there by accident, which means they have probably been ejected from their galaxies by gravitational forces or collisions with other objects. And there could be more of these stars than we realize, but they are simply too dim to be seen from Earth. Stars don't actually twinkle, it's more that we just see it like that from the Earth. It seems like they twinkle because of the turbulent atmosphere of our planet. The light from a star must pass through many layers of the atmosphere. Not every layer is equally dense, so this causes the light to slightly deflect and change in color and intensity. There's one star named Sirius that sometimes twinkles, sparkles, and flashes so much that some people even tend to report it as something extraterrestrial. This is because Sirius is very bright and is often low on the horizon, which means it experiences more of these special effects of the Earth's atmosphere. When in space, astronomers and astronauts who observe stars from there don't see them twinkling. Hey, want to hear something cool? Me, you, your friends, the rest of humanity? We're all made of stardust. The elements that make up human bodies and all life on Earth were formed inside stars. The building blocks of life, such as carbon, nitrogen, and oxygen, were created inside stars, and were eventually released into space when the stars were gone. These elements then became part of new stars, planets, and eventually life on Earth. The iron in our blood was created in the cores of supernovas, which are massive explosions that occur when stars fade. Some say that even the calcium in our teeth and bones is likely to come from exploding stars. The oxygen in our lungs was created in the cores of massive stars before being released into space through supernovas. When you explode planets, things get red hot. Atmospheres are stripped away, stuff is flying apart, everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Sometime before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart, and then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume, 85% of Mercury, and finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1/600 of them. Unfortunately, you won't be able to do that because you pressed the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust, but 12-18 kilo. Then you spot bright, burning meteors flying toward you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach a blue marble of your home planet. What will its insides look like scattered in space? From above, Earth looks pretty. 71% of its surface is blue because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume, 84% of Earth. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 ft thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then the flying pieces get solid again. Ah, it's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 IF. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong it evaporates smaller planets like Mars and Earth. The Sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful. Gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way. Neptune looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals.
At first, it may seem like the sun is burning, but it's actually not true, because the burning of our star isn't chemical combustion, it's nuclear fusion. The sun can't run out of oxygen or stop burning because it doesn't use oxygen to burn. Regular carbon combustion requires oxygen. As soon as there's no oxygen, the process of burning stops. Now imagine a candle. If you cover it, it doesn't have access to oxygen anymore, and the process of burning stops. But in nuclear fusion, the nuclei of atoms are fused together to make new, bigger nuclei. Such changes cause atoms to become new elements. Nuclear fusion doesn't require oxygen or any other material altogether. You just need enough pressure or heat to squeeze the nuclei of atoms close enough for them to overcome their electrostatic repulsion and bond into one nucleus. In 2027, two teams of astronomers discovered a cloud of water floating in open space. It was the largest and farthest reservoir of water ever detected in the universe. It's a cloud of water vapor surrounding a huge black hole called a quasar, 12 billion light-years away from Earth. The environment around the quasar must be unique to somehow produce such giant masses of water. It was formed by energy waves colliding hydrogen and oxygen atoms together. The cloud contains 140 trillion times the entire volume of water on our planet. It could provide each person on our planet with a planet's worth of water 20,000 times over. Wow! Even cooler, astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. Scientists consider it another demonstration that water exists throughout the universe and was present already during its early days. At the same time, before this discovery, scientists had never found water vapor present so far back in the early universe. There is water in our home Milky Way galaxy, but most of it is frozen in ice. Not only water is floating out there in space, alcohol too. In 2009, scientists were examining a massive cloud of gas and dust in the center of our galaxy when they stumbled upon a surprise. There was ethyl formate within the cloud. This chemical is responsible for the sweet flavor of raspberries. They also found one more cool region. This one was brimming with ethyl alcohol, the same type found in many beverages. At the North Pole of Saturn, a mysterious storm is raging. It's ginormous, spanning an area larger than our planet and showcasing a beautiful but baffling hexagonal pattern. No one has understood yet why the storm has such a bizarre shape. After the hexagon was first discovered in 1987, it remained hidden in darkness up to the moment when sunlight exposed it again. Soon afterward, the Cassini spacecraft, designed to explore the Saturn system, provided a series of captivating images and even a video of the hexagonal storm. It turned out to be colossal in size. Its estimated depth is around 180 miles, and the eye of the storm is 50 times as large as the typical storm on Earth. The storm is also changing its color from blue to gold. Winds of hydrogen and ammonia surround the storm and move at more than 300 miles per hour. The storm has several centers. Some of them move clockwise, and others follow a counterclockwise direction. The largest vortex appears to be white. and it's twice larger than the standard hurricane on our planet. As for the hexagon itself, it's a jet stream made up of atmospheric gases. Experts refer to it as just a current of air and weather features. But there is one intriguing detail: a vortex sitting at a higher altitude than Saturn's clouds. It looks like a large towering structure. Saturn's auroras, triggered by the planet's magnetic field, are located atop of the hexagon, giving its appearance a mystical vibe. Astronomers have found a giant, likely active volcano near Mars's equator. It was literally hiding in plain sight. It's ancient and deeply eroded, but seems to be still functioning. There may even be remnants of a glacier ice near its base. That's why this discovery might indicate a promising new location to search for life, as well as a potential destination for future human and robotic exploration. The structure is still awaiting its official name. At the moment, it's referred to as the Noctis volcano. It reaches a height of 29,600 feet and spans an impressive 280 miles across. Such a giant size indicates that the volcano has been active for a very long time. In its southeastern part, there's a thin, recent volcanic deposit, and beneath, glacier ice might still be present. At a distance of 700 million light-years away from Earth, there's a gaping hole, a blank void with no galaxies, stars, planets, or asteroids, literally nothing. The void is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there billions of times over. That's the mysterious Bootes void. It lies in the constellation of Bootes, the herdsman driving the plow around the North Pole. At first, this void had the name of the Great Nothing, but later it was given its current name. Now, we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are enormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bootes void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. There is a diamond planet out there that orbits a star in the constellation of Cancer, completing one full rotation in a mere 18 Earth hours. The planet's scientific name is 55 Cancri e. The radius of this faraway world is twice as large as Earth's, and its mass is 8 times greater. The planet is scorching hot, the temperatures on the day side reaching almost 5,000 degrees Fahrenheit. But the coolest thing about 55 Cancri e is that, according to some specialists, at least a third of the planet's mass could be diamond. That's the equivalent of around 3 masses of our home planet. Sounds like big money floating out there in space. How about we calculate how much this planet could be worth? Wait, someone has already done it, and the number is astronomical, pun intended, of course. It's 26.9 nonillion, and if you're confused by this number as I am, that's 26.9 followed by 30 zeros. Now, for comparison, one of the most expensive diamonds on Earth ever is the Cullion. It costs a whopping $2 billion, and its original weight was a mind-boggling 3,106.75 carats. It was, and still is, the largest raw gem diamond ever found. Later, it was cut into many small diamonds. The largest of them is Cullion 1, which also goes by the name of Star of Africa. It has a carat weight of about 530, but imagine how much bigger and more expansive the Diamond Planet is. Nebulas are gigantic clouds of gas and dust, and some of them can have really unusual shapes, as if they were made this way on purpose. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, this mass becomes so big that it collapses under its own gravity and forms new stars. Among some of the most beautiful nebulas out there, we must mention the Butterfly Nebula. Its wingspan is more than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it formed from a giant gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. It's what probably makes the whole structure look like an hourglass or a butterfly. The Ring Nebula looks like a giant cloud of dust and gas surrounding an old, almost extinguished star. At first sight, it does look like a ring, but astronomers say the nebula isn't a bagel, it's a jelly-filled donut. They must be hungry. The deep space colorful object, more than 2,000 light-years away from Earth, is actually a ring that wraps around a blue ball-shaped structure. Each end of the structure sticks out of the ring's opposite sides. The pillars of creation look like something out of this world. See for yourself. They're located 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old. On a space scale, they're just babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called pillars of creation, an active star-forming region. Look at this famous image. The blue colors represent oxygen, red is sulfur, and green means the presence of both hydrogen and nitrogen. The pillars are also bathed in the ultraviolet light coming from a nearby cluster of young stars. Unfortunately, the winds from those stars are slowly but steadily eroding the magnificent towers of gas and dust. Far out in space, a ghostly super-ancient galaxy is floating all alone. It shines with a faint glimmer of starlight and has hardly changed for billions of years. Astronomers have no idea why it's there or how it formed. Meet DGSATI, a living fossil galaxy. It's as big as the Milky Way, but is nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It might mean that DGSATI was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest to our planet black hole ever discovered. The nearest one is called Gaia BH1. Makes sense. It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of around 9.6 times that of the Sun. That means it's way smaller than the newly found black hole. Gaia BH3 is located in the Aquila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Now look at this marvelous exoplanet. It resembles a giant eyeball hanging out there in space. But it isn't the coolest thing about it. This distant world, identified in 2017, is one of the most promising places for finding life outside our solar system. The exoplanet is called LHS 1140b, and it shows signs of having a global ocean capped in ice. It's that very iris, a huge region around 2,500 miles across, which is constantly gazing at its host star. The planet has a radius of about 1.73 times the radius of Earth, and is 5.6 times as massive as our home planet. The giant eyeball planet orbits much more closely to its star than Earth does. It needs just around 25 days to complete an entire orbit. If the star were similar to our Sun, such a distance would definitely be too close for life to appear on the planet. But instead, it's a cool and dim red dwarf. That's why the exoplanet lies in the habitable zone of its star, where it's not so cold that all surface water would freeze, and not so close that this water would steam away. At the moment, LHS 1140b looks like the most promising candidate for hosting life in our planetary neighborhood. Solar flares are extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. They occur when there's some magnetic disturbance in the sun. Then, magnetic field lines in the atmosphere of our star get tangled and snap. This releases giant amounts of excess energy, including ultraviolet radiation and intense X-rays. These twisted lines appear in sunspots. Those are darker and cooler regions on the surface of the sun. They form when magnetic fields that used to hide deep within our star rise up to the surface. As for coronal mass ejections, or CMEs, which are launched by solar flares, they're sent outward into space. They hit planets, satellites, and basically any objects in their path. Those that come across Earth trigger geomagnetic storms, which in most cases result not only in beautiful auroras, but also in power grid failures and satellite malfunctions. All these extreme solar phenomena, CMEs, sunspots, and solar flares, get much more intense during the peak of the Sun's 11-year-long activity cycle. It's known as solar maximum. Right before this event, the Sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emits powerful streams of radiation, and grows planet-sized spots. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive sooner than that. This planet is as light as a piece of fluff stuck to your jacket. In the scientific world, its name is WASP 193b, but we'll call it the Cotton Candy Planet. It's located around 1,200 light-years from us. We'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin. It has an extremely low density. Combined with other factors, like its high temperature and the infrared brightness of its host star, it makes it special. Interestingly, the planet's radius is just 1.46 times the radius of Jupiter, but its mass is a mere 0.139 times of our gas giant. May I have a close-up here, please? Thank you. See how fluffy it is? It would be absolutely impossible to stand on its surface should you ever reach this distant world. It's not often that you can meet something like WASP 193b at a planetary party. Such planets are rare. Their fluffiness might be caused by their planet stars. Those heat them, puffing them up like a marshmallow that's seen too much campfire action. The planet's super low density makes it a real anomaly among those 5,000 plus exoplanets we have already discovered.
In September 1859, scientists observed the first confirmed powerful solar flare. The Sun threw a large amount of radiation, energy, and plasma material into space. This was a massive and devastating disaster, but it happened 150,000 kilometers away, So it probably wasn't such a big problem, right? Well, actually it was. A few hours after the flare was spotted, telegraph lines stopped working all over Europe and North America. Some of them sparked and caused fires. People realized that the sun was not only the source of light and warmth, but also danger. Scientists called that day the Carrington Event. The good news is, this happened in the middle of the 19th century and didn't cause serious problems for the planet. The bad news is that scientists are warning that in 2025, Earth will experience even more powerful solar storms caused by a coronal mass ejection. This is a giant cloud of plasma, or charged gas. At one time, the sun can throw billions of tons of this material into space. Then all this flies at high speed through space. Some of the material can reach our planet in 15 hours, the rest in a few days. During the journey, it captures and accelerates any charged particles encountered on the way, which increases its intensity and power. And then, this unstoppable array of energy crashes into our planet. It heats the upper layers of the atmosphere, increases its thickness, and disturbs the work of satellites. They slow down and lose altitude. Communication with satellites becomes unstable. GPS is buggy. Data is poorly transmitted. Also, solar-charged gas penetrates into our power grids, transformer booths, and stations. It leads to massive failures that ruin the work of the entire technological chain. A powerful solar attack on several power plants can trigger a power outage in a large city. The internet, phones, social services, networks, nothing will work. We may lose connection with each other. Many large companies would go bankrupt, and the planet may face economic crises. These are big problems, but not the most serious ones. Electric plants serve boiler houses and water pumping stations. Solar storms could stop water from getting to our homes. You wouldn't be able to buy groceries in stores without cash. Of course, we can restore all this, but we will have to live in the Iron Age for a while. But the worst thing is that a prolonged solar storm can suspend food production. For example, this year, a geomagnetic storm caused by solar storms shut down GPS satellites that are connected with modern tractors, so farmers couldn't work. What would happen if such storms happened every day for a year? We would probably start missing many items in supermarkets. Besides, maritime navigation also depends on satellites. Thanks to them, ships calculate the latitude and longitude of their location. If satellites are damaged, ships may get lost in the ocean. Even whales get lost in the ocean during magnetic storms. Many birds navigate with the help of the magnetic field during long flights to the south. So, not only people but also animals may experience serious problems. Solar storms heat the upper layers of Earth's atmosphere and thus make the air thicker. The movement of satellites slows down because of this air resistance. They lose altitude. And one of these satellites is Hubble. Yes, the very telescope that provides us with incredible pictures of space. Scientists say that it will fail much earlier because of solar attacks. You've probably heard on the news that solar activity has recently caused electromagnetic storms on Earth. But fortunately, it hasn't affected our lives in any way. The only problem was headaches, high pressure, and mood swings during those storms. It seems like an ordinary thing, but scientists don't have a consensus on this topic. No one has proven exactly how and why magnetic storms affect our condition. Yes, during storms, the planet's atmosphere becomes less dense, and perhaps this affects our blood pressure just like it happens when the weather changes. So, people with cardiovascular system problems should be careful. But the effect on our nervous system, fortunately, is quite insignificant. It's possible that when people hear about a coming magnetic storm and feel unwell, they experience a placebo effect. But there's also good news. All these charged solar particles interact with atoms and molecules in Earth's atmosphere. This interaction leads to beautiful northern lights. It's good to spend some time away from your gadgets and look up at the sky sometimes. One of the biggest storms occurred on March 13, 1989. On March 10th, the sun ejected a gigantic volume of coronal plasma. The amount of that material was the size of 36 Earths. The solar cloud was flying to us at whopping 600,000 kilometers per hour. and a couple of days later, it crashed into our planet's magnetic field. The collision caused a geomagnetic superstorm. People watched some of the brightest and most beautiful auroras in history. The light show covered most of the planet, but after a beautiful performance, problems followed. The solar storm was so powerful that it went through the atmosphere and reached Earth's surface. First, it disrupted the operation of satellites, and then damaged electrical networks. For example, it destroyed a transformer at a nuclear power plant in New Jersey. Energy companies in Canada went down because of systems overloading. As a result, about 6 million people in northeastern Canada lost electricity for 9 hours. This was the largest power outage caused by a geomagnetic storm. Yeah, there were more powerful storms in the mid-19th and early 20th centuries, but the planet wasn't covered by so many power grids at that time. More powerful storms may occur in 2025. The question is, will we be ready for them? Careful study of solar activity can help us prepare. If we know in advance about an upcoming storm, then scientists can switch off some systems and turn them on afterward, theoretically. If the activity of the sun increases every year, then we will have to come up with new innovative ways to protect ourselves. Who knows? Maybe scientists will cover all our electrical appliances and stations with a layer of special protective material. Anyway, we must do everything possible not to harm Earth's magnetic field, because if this shield disappears, the surface of our planet will resemble that of Mars. But what causes these solar storms, and why do they affect us so much? Okay, imagine a guy with a nice hairstyle who goes to bed. In the morning, his head is a complete mess. The magnetic fields of the sun are similar to this tousled hair. When the sun rotates, these fields burst, get tangled, stretch, and tear. At those moments, they release huge amounts of energy into space. This is not a problem for the sun, as the fields are restored during the process called magnetic reconnection. Such emissions can cause trouble for the planets in our system. When magnetic reconnection happens, several phenomena can follow. One of them you've already heard about. It's a coronal mass ejection. But there's another terrible thing that the sun does, and it's called solar flare. Imagine a bright burst of solar radiation containing electromagnetic waves, and it spreads through space at the speed of light. It takes 8 minutes for this explosive wave to reach our planet. Fortunately, we don't get much damage from these flares because Earth's magnetic field and atmosphere protect us. Strong flares can disrupt radio waves in the upper atmosphere and affect the operation of satellites, but it's nothing critical. Another solar phenomenon is called a radiation storm. These are accelerated electrons and protons that move at a speed slightly less than the speed of light. Thanks to Earth's magnetic field, radiation storms don't harm our planet too much. But they pose a danger to astronauts and satellites. These particles can penetrate human tissues and lead to serious health problems in the same way radiation does, but only if you're in space or flying an airplane in the upper atmosphere. Our moon exploration project started out in 1969. Sure, there have been some problems along the way, but astronomers are certain we'll get back up there pretty soon, and with better knowledge and technology. However, there's an 800-year-old trick that might become way more useful than fancy GPS tech and powerful rockets. It's called the Fibonacci sphere. Some scientists at a Hungarian university stumbled upon this idea while studying the moon. They believe it might be useful to better understand how the moon spins, and how it's a bit squished while it goes around Earth. You might believe that our planet and its satellite are these perfect little spheres floating in space. Well, that's not true. They are in fact like slightly deflated soccer balls because of all the gravity, rotating movements, and tides. The GPS technology we use here on Earth is already adapted to these less than perfect ball proportions. Remember, our planet is a bit flattened at its poles. If we're gonna make a map system for the moon, we need to do the same for its shape, called a solenoid, or what scientists call the moon's version of our Earth's shape. Since the moon is less compressed than our planet, scientists have been taking a shortcut until now. They've been looking at our satellite as a simple ball shape. However, with all these new projects coming up in the following decades, and even some exciting trips we might end up having on the moon, we need to be more precise. Scientists now believe we should get the real data, and start drawing an accurate picture of the moon. Here's where the Fibonacci sphere comes in handy. It's a clever solution that's been used by mathematicians to spread points out evenly on a ball. Scientists recently used it to map around 100,000 spots on the moon, using data previously collected by NASA, and what they found was crucial for our understanding of the moon's shape. For instance, we now know that our satellite's poles are about 0.5 kilometers closer to the center compared to the moon's equator. Sure, it might seem like a tiny detail, but if we adjust our GPS software accordingly before we land on the moon again, it might save us from getting lost up there. This level of math hasn't been done since the 60s for the moon, but we already know it works wonders here at home. So it only makes scientists better prepared for future missions. This isn't the first time people have used Fibonacci's findings to come up with clever solutions. We've also seen it put to work in finance, agriculture, and in computer science. Let's see where it all came from. Legend has it that the Italian mathematician Fibonacci wasn't really that interested in mathematical sequences at first, but rather in rabbits. So he came up with this interesting puzzle. What happens if you place a pair of rabbits in a certain space for a year? He also set some theoretical rules. For starters, all those bunnies come in boy-girl pairs, and they can start reproducing after just a month. Each month, each bunny pair adds one more pair of bunny offspring. The last rule was that all bunnies would be invincible for the year. Doing the math, he got this series of numbers: 1, 1, 2, 3, 5, 8, and so on. If you look at this series again, you'll notice that every number is the sum of the two before it. The first two, that's your starting bunny pair. Next, you'll see the number 2, which is the first pair and their first offspring pair. Word caught on about this interesting sequence, and math lovers began studying it more closely. They started seeing this pattern very often in nature, like in how leaves grow on a plant or how seeds arrange on sunflowers. There's even a little experiment you can do to check it out. Start by grabbing some paper and a pen. Try drawing the Fibonacci spiral. Start with a tiny circle, then go bigger and bigger using those Fibonacci numbers. The first circle should just be a tiny dot on the paper, or the equivalent of 0. Next circle, 1 unit. Another circle, still 1 unit. Keep it going and you'll see that the circles form this spiral pattern. Even as it continues to grow, it keeps its shape. You might have also stumbled upon the Fibonacci spiral as a symbol of hypnosis. In all fairness, there's little evidence you can confuse someone by making them stare into a spiral for a while, but its effects on our focus and our optic nerves can't be ignored. After you've stared at a spinning spiral, you might see how objects get smaller or bigger, depending on the direction of the swirl. It's easy to understand why some experience this sensation as hypnotizing. This interesting series of numbers appears in our day-to-day lives, even if we don't notice it. It can also be used in more practical instances, like converting miles to kilometers. Let's look at the series 1, 2, 3, 5, 8, 13. Pick any two numbers side by side. Say, 13 and 21. Do the calculations and you'll notice that 13 miles is about 21 kilometers. Same with 34 and 55. Music and math might not seem like they're connected, but if you had asked the great Mozart, he probably wouldn't have agreed. It seems he was very passionate about numbers from early on in his career. He loved finding cool number patterns in music, like some sort of hidden messages. His own sister even remembered him doodling math all the time, even on the sides of his music sheets. Some scholars believe he might have even played around with the Fibonacci numbers. If that's really the case, then he might have used the ration to balance out parts of his tunes. What about other types of art? Well, it's also said that Leonardo da Vinci used the golden ratio in his masterpieces, like the Vitruvian Man and the Mona Lisa. Also, when it comes to great pieces of architecture, the Parthenon might have used this pattern too. Anytime you see buildings with columns spaced just right, you can be certain that's where the builders drew inspiration from. The Great Pyramid of Giza is another great example. There's no official record to prove it, but the pyramid shape is so close to the golden ratio that it's kind of obvious. You'll also see this pattern appearing naturally in our environment. Go out in our garden and check to see if you have any pine cones lying around. See those scales? They're set up in a pattern according to the Fibonacci sphere. Even the bones in our body seem to be growing based on the same proportions. We've got one torso, one head, and one heart. Then there's stuff that comes in pairs, our arms, legs, eyes, and ears, for instance. For the number 3, think about the composition of our limbs and the 3 main sections in our hand: the wrist part, the middle palm part, and our fingers, which are also split into 3, by the way. Oh, speaking of fingers, their bone lengths have this ratio too. This design helps our fingers move smoothly, especially when grabbing objects. The Fibonacci sequence can be seen in the way ocean waves curve and how rivers split and flow too. Weather patterns can also follow this rule. Some whirlpools and hurricanes form and spread out in the same way the Fibonacci spiral does. Zoom out and you'll see that spirals aren't just found here on Earth. They're also everywhere in space, and it isn't random. Most galaxies, including our Milky Way, are spirals. Think of it like this. Generally, stars in a young galaxy don't all appear at once. Some are faster when developing, others take their time. This makes gravity pull in different ways, making the young galaxy spin like a disk. As it spins, different levels of gravity stretch it into getting these spiral arms. On the flip side, if all the stars in a young galaxy appear at the same time, gravity just smushes it all into an egg shape, or what the astronomers call elliptical. There's a chance that our entire Milky Way galaxy is located in the so-called space void. It's a region where there's relatively little matter as compared to other corners of the known universe, and it's much less dense than it is elsewhere in the universe. In other words, we might exist in an air bubble in a cake. If that's true, it would mean that we're even lonelier than we thought. In our universe, all the galaxies are constantly moving away from each other. In order to understand how far they move away, scientists use something called the Hubble-Lemaître constant. It's like a speedometer, but for galaxies. However, there's a cosmic mystery called the Hubble tension. It's challenging what we know about the universe's expansion. Scientists used to consider the Hubble-Lemaître constant a reliable guide, but our recent observations question this reliability. The speeds we see in real life don't match up with the distances we calculated and expected. They aren't sure why these measurements don't add up. Researchers followed the moves of supernovas and saw that the universe seems to expand faster around us than it does overall, as if it's actively avoiding us specifically. After considering this, they began to assume that we all might live in a cosmic void. Cosmic voids are vast, empty spaces between galaxies. They make our entire world look like a big sponge. Let's go back to the beginning, just a fraction of a second after the Big Bang. Right after the beginning of everything, the universe was a hot, compressed plasma. It only had very tiny variations in density called quantum fluctuations. After the Big Bang, the universe began to expand. Those quantum fluctuations grew together with it, creating regions of varying matter density. Because of that, the universe didn't expand everywhere uniformly. Instead, little claps of matter began to gather together over a long time, creating massive structures. Galaxies. Galaxies are arranged in huge walls and filaments with enormous gaps in between. And these gaps are the voids, also known as dark space. These voids aren't truly empty. In fact, they actually hold more than 15% of the amount of matter found on average throughout the entire universe. They still contain gas, dust, dark matter, and even stars and galaxies. However, they have less density than regions of galaxies, about 1/10 of the average matter density, which is why we consider them nearly empty. Usually they have a diameter ranging from about 30 to 300 million light years. That is an enormous distance, even on a space scale. For comparison, most planets and nebulas we've found so far have a distance of hundreds and rarely thousands light years away from us. In the case of voids, if you were in the middle of one, it would just look like seemingly eternal darkness. The closest stars would be so far away that they would be almost invisible to you. Some of them are especially large. They're known as supervoids. The largest known one was creatively named Giant Void. It's so big, it's impossible for us to even imagine. 1.5 billion light-years away, with a diameter of 1 to 1.3 billion light-years. Yes, it's basically a giant dark vacuum, but even this giant vacuum isn't entirely empty. The Giant Void houses 17 separate galaxy clusters within its expanse. However, it might not be the biggest emptiness in our world. There's this thing called the CMB cold spot. It's this unusually large and chilly area of our universe that we saw through the microwaves. It really stood out on the map of our universe with its unexpectedly low temperatures, and scientists have spent many years trying to figure out what this thing is. In 2015, scientists proposed that this place might be a super void, and probably the largest one ever. Being even more original with this one, they called it the Great Void. If it's true, this place would be an emptiness about 1.8 billion light-years in diameter, about 1,000 times larger than typical voids. Not everyone thinks that it's possible, so scientists keep arguing over this one for a while. There's another interesting theory going about this place. One researcher suggested that this place might have been a trace from our collision with a parallel world. It's a pretty bold hypothesis, but unfortunately, there's no way for us to confirm or deny it with our current technologies. In any case, as the universe expands, these voids will grow, and the walls connecting galaxy clusters will stretch and break. Eventually, the voids will merge, leaving gravitationally bound galaxy clusters as islands in the expanding emptiness. In other words, sooner or later, the great emptiness will consume everything in our world. So, it turns out, we might be a rare occasion in a supervoid, one of the 15% of matter. This would explain why we're surrounded by relatively few galaxies. This discovery, if true, challenges the standard model of cosmology which we created with Albert Einstein's help. It would mean that gravity in general behaves differently than what we expected. According to the standard model, such a significant underdensity shouldn't exist. Because of that, scientists will have to explore and consider this idea thoroughly. It might just challenge our very basic understanding of physics. The scientists called this the local hole. The discovery of the local hole may hold clues to explaining the Fermi paradox. Maybe in this specific part of the universe where we hang out, the chance of intelligent life developing anywhere nearby is very low. Perhaps all the sentient beings hang out somewhere beyond our super void. But that doesn't mean that we should lose hope, or that life anywhere nearby is impossible. In fact, life in the universe might be much more common than we previously thought. We know that the inner planets, like Mercury and Venus, are inhospitable due to extreme conditions. However, Venus looks interesting because, even though it's a crazy toxic planet, scientists believe that it was very Earth-like in the past. It could have even hosted life. Unfortunately, it was too close to the sun, and all the nice conditions evaporated over time. But there's a possibility of microbial life surviving in its high-altitude clouds. Mars, a cold desert, also might have been a friendlier place in the past with rivers and lakes. Though now it lacks a protective atmosphere, ancient life might have existed there. In that case, it would leave potential fossils, and underground microbes could still survive. We've discovered some signs of them, but are still debating whether this stuff was truly organic or not. The gas giants, like Jupiter and Saturn, and ice giants are not ideal for life, but their moons offer hope. Europa has an ocean beneath its icy surface, making it a potential hotspot. Enceladus releases water into space, carrying complex molecules that hint at interesting possibilities. And Titan is especially unique. It has liquid bodies on its surface, rivers and lakes of hydrocarbons. While its frigid temperatures aren't great for life, scientists ponder if it might host life with a different kind of chemistry. However, it will take us decades to check all these celestial bodies and study them properly. We haven't sent anything so far since the times of Voyager 2, but if we're lucky, we might explore our solar system during the 21st century. In any case, there's a lot of potential for life, even in our solar system alone, not even mentioning all the planets and galaxies we've found nearby. Our estimates suggest that the observable universe, the one we can see, might host around 5.3 trillion habitable worlds. One of the most likely candidates so far is Kepler 186f. It's a potential Earth-like planet, just 10% larger than Earth. This planet orbits a red dwarf star, which is a star a bit dimmer, colder, but more long-living than our Sun. And it's only about 490 light-years away, which may sound like a lot, but remember what distances we've discussed with supervoids. So, even if we really are in a supervoid, we're still lucky to have many galaxies and planets around. And if one day we'll find a way to travel through the universe, leaving the local hole probably wouldn't be a problem. Shop Pirate. R! Hold onto your telescope, space rat. Scientists have made an astonishing discovery. They've found the ancient heart of the Milky Way galaxy. But what is this ancient heart? And what does it tell us about the history of our galaxy? Let's find out. Kachunau retroskau, chatue purisei, our chassis datiers, chatis errors, aichachain site service. Baicheptizau, propai, shitwite sir, ain't thou. Pirate, is that it? Don, yes, and thank you, Captain Jack. Pirate, my pleasure. R, he leaves. That's right, on. What can I say? He's a space pirate. The Milky Way isn't just a candy bar, but a majestic spiral galaxy that's home to billions of stars, planets, and other celestial objects, and it's all spread out over a distance of about 100,000 light-years. The Milky Way has a distinct shape, with a central bulge and spiral arms that extend out from it, kind of like what I look like from the side. The spiral arms are like the suburbs, where the stars are more spread out and the neighborhoods are quieter. They're made up of gas, dust, and stars that all move together in a circular pattern around the center. In between the spiral arms, there are vast regions of empty space, known as interstellar space. Here, you can find wispy clouds of gas and dust, as well as some of the most spectacular sights in the galaxy, like massive star-forming regions and colorful nebulas. The Milky Way is also surrounded by a huge halo of dark matter, a mysterious substance that we can't see but can feel its gravitational effects on the galaxy. This halo helps to hold the galaxy together, and it extends out much farther than the visible parts of the Milky Way. And finally, there's the center. Here, the most action happens. In the center of the Milky Way, there is a supermassive black hole, which is about 4 million times more massive than our Sun. Sagittarius, a star. This black hole is responsible for some of the most energetic events in the galaxy, like the emission of powerful jets of energy. Remember the famous first photo of a black hole that flew across the internet? It was Sagittarius, a star. We managed to capture this black hole because it's the closest one to us. All in all, the center of the Milky Way is full of stars that are tightly packed together, forming a dense cluster. And it was here that astronomers recently made a new epic discovery. The heart of our Milky Way galaxy has been found. And boy, oh boy, is it an old-timer. Hey, who are you calling an old-timer? A team of brilliant scientists has found a cluster of 18,000 stars, born right after the Big Bang. Together, they form the ancient nucleus of our Milky Way. These stars date back to a time when our galaxy was just a wee little baby, a mere collection of proto-galaxies, huddling together to form a bigger and better thing. The scientists called it the poor old heart of our Milky Way. Can you believe it? These ancient stars are over 12.5 billion years old. And yeah, maybe they account for a mere 0.2% of our galaxy's total mass. But that doesn't matter. These stars are the building blocks that formed the core around which all the other stars and planets took shape. But how exactly did they become this heart of the galaxy? How did they form? And how did we discover all that? To answer these questions, we'll have to plunge into the past. A very, very distant past. Once upon a time, almost 14 billion years ago, there was the Big Bang. Our universe was born. At first, it was incredibly hot, but as time passed, things started to cool down, and tiny pockets of gas began to clump together due to the force of gravity. These were the first galaxies. The Milky Way is one of these galaxies. It also started as a small clump of gas and dust, but over time, it began to take shape. The very first stars, protostars, began to form within the clouds, and their gravitational pull caused more stuff to come together. This process continued for millions of years until the Milky Way was formed. But to learn the history of our galaxy in more detail, we need to find these protostars, and this is far from an easy task. Researchers have discovered the ancient heart, using a neural network to analyze data from the European Space Agency's Gaia mission. The Gaia telescope is a space observatory launched by the European Space Agency in 2013. Its job is to map the position and movement of more than 1 billion stars in the Milky Way galaxy. 1 billion stars. That's like counting every grain of sand on a beach. It's a huge job, but Gaia is up to the task. So, how do they do it? The telescope has 2 cameras that take pictures of the sky at the same time. These cameras are so powerful that they can detect stars that are 1 million times fainter than those visible to the naked eye. Gaia takes many pictures of each star, and this allows us to track their movements with incredible precision. Thanks to the data collected by Gaia, astronomers are learning more about the structure and history of the Milky Way. They're discovering new details about the stars, including their ages, temperatures, and chemical compositions. Gaia is also helping astronomers search for exoplanets, or planets that orbit stars outside of our solar system. So, for this research, astronomers use Gaia and the most accurate 3D map of the Milky Way ever compiled. They had to analyze around 2 million stars to find the primordial group. One way that astronomers can determine the age of stars is by looking at its brightness and temperature. This way, they study a brief phase of stellar evolution known as subgiants. But imagine searching through the huge center of the Milky Way for the tiniest group of stars that are older than 12.5 billion years. This is like searching for a needle in a haystack. Luckily, they had a trump card up their sleeve: metals. You see, in the early universe, the cores of these stars were so hot and dense that they were able to smash atoms together to form heavier elements. These heavier elements are called metals in astronomy, even though they're not really metals like the ones we're used to. The more massive the star, the more metals it can create during its lifetime. When the life of the first stars came to an end, they made a big boom and scattered these metals all around. Metals mixed with other gases and joined the newborn stars, and so on. As time passed and the universe got older, more and more generations of stars formed, each one richer in metals than the last. Can you guess what that means? The older the stars, the less metals they should have. So now it was time for some galactic archaeology. The team taught the AI to find the metal-poorest, most ancient stars, and it succeeded. It found a huge cluster, and all of them were within 30,000 light-years from the center of the Milky Way. Then, they separated out the stars that formed the ancient heart from the stars that originated in a dwarf galaxy, and finally, we were left with the original stars around which the Milky Way grew. This discovery is incredible. It reveals the remnants of the Milky Way's earliest history. It turns out that simulations of the Milky Way's formation were spot on. The old stars existed just where they were predicted to be. Just imagine, the stars that remember our universe as a baby are still hanging out in the center of our galaxy. Isn't that mind-boggling? So why is this such a big deal? By studying these ancient stars, scientists have discovered some incredible things. For example, they've confirmed that the Milky Way's core began its life stationary and only picked up rotational speed as it grew. Imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in incredibly hot temperatures. No wonder it will take a long time before we'll be able to stand on this planet. Up to 3-sec pause. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days. Basically, a half a year. Just like with Venus, a day there takes much longer than a year. Since it's the closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it will be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's north polar region, especially at those sunlit yellow spots inside craters. These are indications of water ice. Turns out, water is much more common in space than we thought. Sucker 3-sec pause. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But turns out, Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons. Standing at a staggering height of about 13.6 miles tall, it's even taller than Mount Everest. It was formed by the eruption of low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out, they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Marsquakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar yet different the planets are. Achpawar 3-sec pause. Saturn's iconic rings might hold a secret linked to Earth's ancient past. The rings are composed mainly of ice particles and debris, and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons, or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. While Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune also have their own sets of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its north pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think that it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. 5. 3 sec pause. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that has been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible. Nothing like we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the 8th and farthest planet from the Sun, also has its own great dark spot. Just like with Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant, and just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 1,200 miles per hour. What a drama queen. But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like, in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover more interesting things in outer space in the future. What if the sun went boom? Well, you can guess that it would be super bad news for us. This was sure a short video, huh? No, wait, I have more. If the sun blew up, chaos would ensue in our solar system. But scientists tell us that it will certainly happen one day. But why? How exactly would events unfold? And is it possible for us to somehow survive this event? Hey, let's delve into it. First of all, get ready for a journey to the sun's core. The sun's heart is packed with hydrogen atoms having an out-of-this-world dance party. These atoms are so excited that they smash into each other with all their might.
And when they collide, something magical happens. It's called nuclear fusion. And in this fusion fiesta, the hydrogen atoms combine to form helium atoms, a chemistry experiment on a grand scale.
During this nuclear fusion, a teeny bit of mass from the hydrogen atoms is transformed into a massive amount of energy. It's Einstein's famous equation coming into play. Energy is unleashed in the form of light and heat, radiating outwards to brighten up the entire solar system. And once all these processes get going, a bunch of energized particles called photons join the fun. These photons are like tiny packets of light, bouncing and zipping around in all directions. They play a crucial role in carrying the sun's energy through space, illuminating our world and warming our cozy planet. But to keep all this going, so that the atoms don't escape and create complete chaos, the sun's core needs to be under tremendous pressure. This pressure comes from the immense weight of the sun's outer layers pressing down on the core. The outer layers are squeezing the inner core, but the inner layers don't give up. The energy created from fusion and the bustling photon party tries really hard to escape the sun's core. But the core is so dense, like me, the pressure is so big that the energy takes its sweet time to make its way out. It bounces around, gets absorbed, and re-emitted by other particles. Eventually, after a long time, it reaches the sun's surface and zooms off into space, reaching us as sunlight. So, now you know how the sun works. Now what happens once it reaches the end of its life? Well, here's the twist. Our sun has a limited supply of hydrogen fuel. In about 5 billion years, it will run out of its fuel. After that, the star will undergo some big changes.
Now pay attention, because there's pretty chance that we're all going to miss this.
First, the sun will puff up and become a red giant, expanding like a balloon. It will grow so big that it will swallow up the inner planets, including our beloved Earth. Talk about a sun taking up all the space, so we won't even see the end of our sun unless we move somewhere further away. After the red giant phase, the sun will shrink a bit. Its outer layers will fade away into space, leaving behind a beautiful planetary nebula. It will be revealing its glowing core. Ooh! The core, now filled with helium,
will start sounding weird.
And will also start fusing heavier elements like oxygen and carbon. These reactions won't be as energetic, like a party with less dancing and more chill vibes. Eventually, even the helium will be used up, and the sun will become a compact white dwarf, a stellar retiree enjoying its retirement home. Scientists estimate that the sun has about 7 to 8 billion years left before it dims its lights. Don't worry though, by that time, humanity might have traveled to far-off galaxies, or maybe even evolved into amazing space beings. So, our sun won't go out with a bang like fireworks. It's not big enough to become a supernova or a black hole. Those stellar superstars need way more mass than our sun to pull off those cosmic tricks. But what if it blew up very suddenly? Just like an abrupt event without any reason? Well, let's see. Imagine this. The sun goes boom, and Earth is in for a wild ride. The event unleashes an insane amount of energy, sending a shockwave racing through space at the speed of light. It takes about 8 minutes for this shockwave to reach Earth. Why? Well, the sun is a whopping 93 million miles away from us on average. So, it takes a little over 8 minutes and 20 seconds for the sun's light to travel all that distance and reach us. But let's talk about the event itself. It would be a great sight to witness, but sadly, it would also be the end. Roll credits. The crazy amounts of unleashed energy would cause the sun to expand rapidly, again, swallowing up the inner planets, including our Earth. And that's not all. Brace yourself for a massive burst of radiation. The sun would unleash a torrent of supercharged particles. We're talking about X-rays and gamma rays, the kind that can seriously mess things up. When these high-energy particles hit the atmosphere, they go wild, causing all sorts of chaos. They ionize the atmosphere, creating a ginormous electromagnetic pulse. This pulse is like a shockwave for electronic devices. It fries them, zaps them, and leaves them useless. So, if your gadgets aren't protected, they're in for a rough time. Speaking of rough times, after that, it's instant vaporization for our planet. But the sun's grand finale doesn't just mess with Earth, it wreaks havoc on the entire solar system. That massive burst of energy would be crashing into everything in its path. Planets and other objects get knocked out of their cozy orbits, causing chaos and unpredictability. The asteroid belt between Mars and Jupiter? Kapow! It's gone, obliterated, or scattered to the cosmic winds. And even planets that will survive this event would probably go off their orbits to wander somewhere. And let's not forget about the outer planets, like Jupiter and Saturn. these giants generate their own internal heat, which keeps them cozy and attracts lots of moons. But the sun's boom would steal their warmth, turning them into incredibly cold places. And now that we've discussed how catastrophic would all this be for everything in our solar system, let's ask the logical question: can humanity make it? The short answer is no, we wouldn't make it. Everything would be wiped out, except maybe some sneaky bacteria hiding in the shadows. But in a crazy scenario where the sun gave us a heads up about its plans, we might have a fighting chance. If we knew in advance and had time to prepare, we could get our survival gears turning. So, what could we do? Since Earth itself won't survive the sun's tantrum, we'd have to move somewhere. Remember how we mentioned that not all planets would be completely destroyed? Well, sadly, the ones closest to the sun, Mercury, Venus, and Earth, would disappear. So, the easiest option would be to move to some other solar system with its own Earth-like planet. But what if the Earth somehow managed to survive this catastrophe? Let's not think about how it happened and just discuss the consequences. Well, our climate would go crazy. During the first moments of the sun's kaboom, the radiation and particles would crank up the temperature big time, like a never-ending heat wave. We're talking major greenhouse effect. The oceans would evaporate, creating thick, fluffy clouds that trap heat and refuse to let it escape into space. And after that, without the sun's warm embrace, the Earth would quickly become an icy freezer. So, we'd have to think outside the box. One idea would be to take shelter deep underground, where we won't be that much affected by radiation and sudden temperature changes. As you dig deeper, the temperature rises. So, with the right tools and resources, humanity could hunker down in fortified bunkers, surviving for a couple of years without the sun's rays. Why just a couple of years? Well, remember how we said the sun is a gravity center of our solar system? Without it, Earth would be adrift in search of a new center of gravity. Imagine our planet, our trusty satellite, the moon, and all the other planets slowly floating away into space. Luckily, our trusty sun is hanging in there, keeping us warm and shining for many more cosmic adventures to come. So we're safe for a few billion years. But it's always fun to imagine impossible scenarios, so stay tuned for more What If? Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda, the shiny lunar ball, or a curved banana or half of a coin, depending on the phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo mission, where astronauts went to the moon and gathered information themselves. Plus, they have used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, like planets or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves. And by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron. Just like Earth's, it's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers have also stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history, as well as the history of our entire solar system. One of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth in its early stages and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive, molten Earth. I mean, not so big compared to what is left. If you put a US nickel next to a single green pea, you'd get a good idea of how big our planet is compared to the moon. This chunk was then sent into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet, and roughly the size of Mars. It makes sense. Earth and the moon do have similar compositions, after all. Of course, there are other ideas about how the moon formed. One says that the gravitational force of our planet captured it. That means the moon was just an object innocently passing by when it suddenly got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the moon from Venus. In that case, the moon shouldn't complain. I guess the view is way better here. So yeah, the moon and Earth are similar when it comes to rocks and some minerals. But the moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the moon don't contain water, but that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the moon's surface. One of these astronomers, Michael van Langren, thought these spots looked like oceans, so he called them Maria, which means seas in Latin. Other astronomers also made maps of the moon, and they used the term Maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth, flat areas called basalt plains. In the late 1800s, one skywatcher, William Pickering, studied the moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So, scientists thought that any water on the moon would just disappear right away. They believed the moon was totally dry. But then, in 1961, one physicist, Kenneth Watson, had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. So, water ice could exist in these dark areas because they are extremely cold, and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So, everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we had been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So, there are no oceans like we have on Earth, but at least there's something. But the question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So, there is some evidence that water came there from comets hitting its surface back in the old days. Or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more about, for instance, all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then what if there are some of those elements stuck in the ice on the moon too? Could it be that the entire universe is nothing more than just an atom? When you look at a diagram of an atom, which is a building block for all matter, you can see that some patterns in the universe repeat. Our solar system is a great example of that. There's a giant central star and a couple of smaller planets that circle around it. You observe the same arrangement outside of our galaxy too, with exoplanets orbiting their stars. And you can also witness that principle on a smaller scale. It's the way particles called protons and neutrons move around the center of an atom, which is called the nucleus. So, imagine you have a bunch of positive magnets you're trying to stack together. They keep pushing each other away, right? That's what's supposed to be happening with the protons in an atom. They're all positively charged, so they should be repelling each other and flying off in all directions. But atoms do exist, so there must be something holding them together, and that something is called the strong interaction or strong force. The nucleus makes up less than 0.01% of the volume of the whole atom, but it usually takes up over 99.9% of the mass of the atom, once again similar to our sun. Anyway, this strong interaction is like a special type of glue that holds the protons and neutrons together in the nucleus of an atom. In a similar way, gravity prevents us from flying away from the ground into the darkness of space. Now, this glue comes from some really small particles inside protons and neutrons called quarks. These little guys have a strange kind of charge called color. It's not like the colors we see around us. It works like a code that helps quarks stick together inside their host particles. And this code also seeps out and helps hold protons and neutrons together in the nucleus. In a way, quarks are like little builders that are working together to build atoms that make up everything around us. The Big Bang was said to be a magnificent moment when we got time and space. It's the story we use to explain the evolution of the universe. In the beginning, there was only a very, very small ball of matter the size of a peach, but with a temperature of more than 1,000,000,000 degrees. Ow, that's hot. And this bang in the name doesn't mean there really was an explosion in space. This peach started spreading around, and space was just appearing everywhere. It gave rise to atoms, molecules, stars, and many celestial bodies that filled the empty space of our cosmos. Basically, all the elements that make us formed within a few minutes at the earliest stages of the universe. Let's say, like 100th of a billionth of a trillionth of a trillionth of a second. Oh wait, give me a second to process that. Alright, moving on. The growth was incredible at that stage. The universe spread exponentially, and managed to double in size at least 90 times. Like me during the holidays. Haha, I love chocolate. After the Big Bang, the universe was a hot and dense soup of particles, too hot for atoms to exist. But 380,000 years later, it cooled down enough for electrons to mix with nuclei and form atoms. This is a process we call recombination, and it's what made the universe transparent. Think of it like turning on a light switch. Suddenly you can see it all. But just because the universe became transparent didn't mean it was bright. It was a dark period as there were no stars or galaxies yet, like a big empty canvas waiting for something to be painted on it. It wasn't until much later, as the universe continued to evolve, that stars and other bright objects started to form and light up the darkness, and it went on evolving, all the while filling up with planets, asteroids, galaxies, and other things. Okay, so that's the story we've been told for the past couple of decades, and a pretty good one, I should admit. Scientists have studied it so much. They observed the leftover electromagnetic radiation from the young universe. They measured the presence of the lightest elements, only to realize they all line up with the story of the Big Bang. New theories don't say the Big Bang didn't happen. It's a good picture of the cosmos in its early stages, but it's like an unfinished puzzle with some important parts missing. We can't explain what happened before the Big Bang using our current physics, so we need some new math to explain tricky parts, like the so-called singularity. It's the point of infinite density, remember? From the beginning of the Big Bang. And that's where string theory comes in. Like a superpowered toolkit that can handle gravity and all other forces combined. Now, one of the ideas that string theory has given us is the ekpyrotic universe. Imagine a big fire that sparks off another fire, and that fire sparks off another fire, and so on. Well, in this scenario, the Big Bang wasn't the beginning of everything. It was just one part of a bigger process. It's the idea of the cyclic universe, a never-ending roller coaster ride, with big bangs as beginnings and big crunches as ends, happening over and over again, potentially forever. It's like the universe is constantly hitting the reset button, and does it in a really fun way. We could look at this singularity, according to some theories, as a single particle in a much larger system, much like an atom is made up of subatomic particles. And considering all that, the idea says every nucleus of an atom could have a universe inside of it. So our entire universe is just a tiny part of an atom in a much larger universe made of atoms with more cosmoses, with more atoms, with more cosmoses. So twisted. The early versions of the idea of the cyclic universe still had one big issue. They didn't match up with our observations of the cosmic microwave background, which is a fossil light that shows how the universe looked when it was only 380,000 years old. So, in March 2020, two physicists from Canada, Robert Brandenberger, Ziwei Wang, published a study that revealed the math behind the cyclic universe that we had missed earlier. If we focus on the moment when the universe shrinks to an incredibly small point and then bounces back to a Big Bang state, we might be able to match up with our observations after all. It's just that we need to wait for more new experiments to fully test this idea. The Grand Unified Epoch. That's what we call the time when the universe was still young. At that time, matter and antimatter, which are like mirror images of each other, existed in roughly equal amounts. But since they are opposing forces, when they come into contact with each other, they destroy each other in a powerful explosion, like fireworks. This means that even though matter and antimatter were constantly created and destroyed, somehow there was always a little more matter than antimatter, which is good, cause otherwise we wouldn't have anything left. As time went on, particles started to stick together and form more complex things like atoms and molecules. And eventually, stars formed and created even heavier elements. But someday, a long time from now, all those stars will burn out. When the last star slowly cools and fades away, the universe will turn into a dark void without life, light, or anything we know or assume there is. At some point, voracious black holes will eat all the matter in space. Eventually, even those black holes will evaporate away into the tiniest amount of light. Our cosmos will continue to expand. The light will become spread out and unable to interact with anything. So all activity in the universe will stop. Space will become a vast, empty void with no stars, planets, or anything else, and will end there. Or just begin, and maybe that's where we'll meet again. Hey look, some magical stuff is happening around you. Let's check out some real photos of overwhelming phenomena our Earth offers, and I'll chat about the science behind them. The rainbow-colored scarf cloud is a very rare natural phenomenon. World Meteorological Organization says that this kind of cloud is called pileus clouds. Here's how this rainbow scarf cloud takes shape. There are accessory clouds that depend on a larger cloud system in their development. An accessory cloud widens horizontally and gets shaped like a cap at the top. It attaches itself to the upper part of another cloud. These clouds don't last long, similar in time to a regular rainbow. The main cloud underneath eventually rises and absorbs the rainbow cloud. Who wants to see the ocean glowing and glittering like the sky full of stars? This phenomenon is called bioluminescence. When it happens, waves start sparkling neon blue, thanks to a natural chemical process. Living organisms, such as tiny crustaceans and algae, use bioluminescence to trick predators, attract prey, or find potential mates. Sparkling nightlights have been photographed across Australia and the Indian Ocean. This form of ice is called hair ice. It looks like cotton candy, but it melts away with the sun, not rain. Hair ice is a very unusual phenomenon, and it only forms under specific conditions. It grows on the surface of particular kinds of wood at temperatures below 30 degrees Fahrenheit. If the weather is calm and humid, the hairs can grow up to 8 inches long. In 2015, scientists discovered the fungus responsible for this smooth, silky ice hair. The presence of this fungus leads to a process called ice segregation. The fungus prevents ice crystals from gathering into more stable shapes. I mean, ice can still form on these branches when there's no fungus, but it would be shaped just like normal, not hair-like, ice. So what does this fungus do to make this magic happen? Due to the liquid near the surface of branches is in contact with chilly air. This creates a thin layer of ice. It blends a thin layer of water between the ice and the wood pores. This results in a suction force that pushes the water out of the pores toward the ice at the surface. It freezes there and adds to the existing ice layer. The process repeats over and over. Here you go. Thin hairs of ice are pushed out of the wood. Lake Baikal in Siberia is famous for its crystalline waters. It's the largest freshwater lake on the planet by volume. It contains 20% of Earth's freshwater. It's also very wide. To put it in perspective, it's larger than Belgium.
Plus, it's the oldest lake in the world, about 25 million years old.
And when it freezes during the winter, large shards of transparent ice form on its surface. They appear turquoise because the lake has clear waters. These gem-colored ice structures on the lake's surface are called hummocks. Hummocks are ice splinters. When fierce winds around the lake push its waters into waves, they freeze into these turquoise blocks. Hummocks can be 32 to 39 feet high. Take a look at Naga fireballs. This natural wonder occurs in a specific area around the Mekong River in China. They appear throughout the year, but they're more common during the full moon in late autumn. How they appear is a mystery. These fireballs seem to rise from the water. They can go as high as 985 feet. They are like fireworks, disappearing just as rapidly. They typically have a reddish or orange glow. Did you know that earthquakes emit light too? It turns out that earthquake lights have been around for centuries. They appear before, during, or immediately after an earthquake. They're generally white or blue. The lights rarely last for more than a few seconds, so it's hard to capture them on camera. Yet, on rare occasions, they can shine for up to 10 minutes. Sometimes, they are at the epicenter, while at other times, they're seen up to 250 miles away. They have been spotted over the ocean, too. Scientists know for sure that how powerful an earthquake is somehow influencing this phenomenon. The lights have only been reported during earthquakes rating 5.0 or more on the Richter scale. Scientists have some theories, but it's still a bit of a mystery why the lights exist in the first place. Moonbows have similar principles to rainbows. They occur when the light gets reflected off water droplets in the sky, yet they are much rarer than rainbows. They can appear only under certain conditions. When the moon is very low over the horizon, the sky is dark, and water droplets are in the part of the sky opposite the moon. Halos, also known as circle rainbows, are an optical phenomenon forming high in the sky when the light gets reflected off ice crystals. They look like large circles of white or colored light circling the sun or the moon. The next one is not as rare as the others just mentioned. A sinkhole forms in the ground as a result of some form of collapse of the surface layer. Most sinkholes are caused by the chemical dissolution of carbonate rocks. They're usually circular and vary in shape and size, both in diameter and depth, and you don't want to drive into one of those. A fire whirl is a whirlwind induced by fire. Most of the time, it's composed of flames or ash. This phenomenon is also sometimes called a fire tornado or fire twister. It's pretty clear how it got this nickname. It looks like a tornado and it's made of fire. Yet these terms usually refer to a separate thing, where a fire has such intensity that it creates an actual tornado. Fire whirls are different. They don't usually count as tornadoes as the vortex doesn't extend all the way from the ground to the cloud base. Lenticular clouds are usually in parallel alignment to the wind direction. They have a particular shape. I mean, look at it. That's what people imagine when they think about a spaceship of visitors from outer space. I'm at shot wagers and guess mean. Many people dream of witnessing this one. The Aurora Borealis, or the famous Northern Lights. It's a free natural light show in the sky. Charged particles from the sun strike atoms in Earth's atmosphere. Then they cause electrons in these atoms to change to a higher energy state. Eventually, the electrons get back to a lower energy state. That's when they release photons of light. Obviously, Nordic countries are the best places to see this show. But hey, you can see the Northern Lights in Scotland too. The morning glory cloud is a very long rolled cotton-like cloud. It's seen occasionally in various parts of the world, but there's one place on our planet where they occur on a regular basis. It's the Gulf of Carpentaria in northern Australia. These clouds can stretch for 620 miles. Plus, there can be more than one morning glory cloud at one time. So far, we have seen moonbows, halos, and many other phenomena. But how about looking at a fire rainbow? The fire rainbow is much easier to say, but the real name of this thing is a circumhorizontal arc. Say it with me. Circumhorizontal arc. Very good. It's another cool optical phenomenon that occurs in cirrostratus clouds. Check this out. The next two cool facts are related to animals. What would you do if a million butterflies flew over your head? This might happen when you see monarch butterflies while they're migrating to Mexico or Southern California. These butterflies cannot cope with cold winters, nor can I. So every fall, they migrate either to the south or west, where it's warm all year long. This is a field completely covered with spider webs. This phenomenon only occurs when spiders flee from floods or some other kind of natural disaster. When they leave, they find a higher place to spin their webs. Usually, such a place is a tree or an agricultural field. Since many of them gather in the same safe region, they all make their webs at the same time. Doesn't this huge spider web look like a thick blanket? Yeah, you go lie down in that. Just kidding. Have you ever come across unique natural phenomena? Comment below and let me know. Okay, here you are, in the middle of the ocean. It's endless, but you can't see it, because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kinda dark, but it's not that bad. These water worlds are more interesting than they may seem. So let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans, its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.0025%. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it will have a rocky surface. If it's bigger, it will turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we've found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small, dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our sun and 300 times dimmer. Scientists wouldn't worry about it at all. But back in 2009, they noticed that this star has one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier. But at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it. But it wasn't a gas giant either. Well, actually, we only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far scientists haven't been able to find anything there. No hydrogen, no helium, no water. Nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.14 astronomical units away, which is less than the distance between the moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 535 degrees. Whew, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? That's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So, that's it for the creepy Gliese 1214b. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of Super-Earth. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though. This ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars, so potentially, yes, there may be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There also should be some micro-elements and minerals, and unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up! There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability is that they'll bring something like this into the ocean, and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there, but if it exists, then surely something could have originated there. And who knows? Maybe one day we'll be able to visit such